Now at the end of this lecture, I would like to discuss with you another application example, which is the synthesis of paracetamol. And as you all know, paracetamol is an important painkiller. And if we now have a look on this molecule here, which is paracetamol, we can derive, based on the name already, the functional groups. So we have this para in the name, which indicates a para substitution on the benzene ring. And then we have the ending ol, which is an alcohol, so this hydroxide substituent. And then we have something like acetamido, and this is the acetamido group here on the second substituent. And then we combine all these and we end up with paracetamol. And the classical synthesis approach is very similar to what we just learned. So we start with a phenol, and then we selectively substitute in para substitution. And herefore we need to do a nitration. However, as we just learned, hydroxide substituent is a 2,4 directing activator. Therefore, we will not selectively form this 1,4 substituted benzene, but also the 1,2 substituted one. And after this nitration, we then have a second substituent, which is this nitro group. And then we need to reduce the nitro group towards an amino group, which is done in the second step. And then the final step is the acylation of the amine with an acetic anhydride. And then after these 3 steps, we end up with paracetamol. However, as this reaction is not efficient enough for industry, we will now also discuss the industrial route. And similar to the classical approach, the industry also starts with phenol, but then the first step is a direct acylation with acetic anhydride and HF, which is very aggressive. And then in the second step, the carbonyl group is transformed into an oxime, which we didn't discuss yet, but we will discuss in the coming lectures. So we will replace this oxygen atom with a nitrogen atom, which contains a hydroxide group. And in the last step, we perform a so-called Beckmann rearrangement, whereby the oxime is rearranged into an amide. Then we have paracetamol. So this was the application example for substituted benzenes. And corresponding to this lecture, you can exercise the word examples 22.3 and 22.4. And also you can do the end of chapter question exercise 3. Furthermore, in preparation for next lecture, please start already reading chapter 23.1 on the pages 1056 until 1072.